Hi, boys and girls. Welcome back to the drive-thru. This is 13-7, number 24. Okay. The question says, in triangle AOB, A is the point 6,0. B is the point 0,8. And O is 0, 0, the origin. Okay? Part A says, find to the nearest tenth the volume of the solid formed by rotating the triangle about OA. Well, I better widmapoi. Okay? So, A is 6, 0. B is 0, 8. And there's O. Okay, one more time. Part A says rotating it around OA. Okay? So if we're rotating it around OA, here's our triangle. We're rotating it around this line. So this is going to be, how do I want to draw this? It's going to look like that. Can you guys picture that? Okay. Now I'm going to color this in because that's what it would actually look like. And what do we have formed? We have a cone formed. Okay. What's the volume for a cone? Volume is 1/3 area of the base times the height. Okay? So what's the area of the base? 64 pi. And what would be the height of this cone? Times 6. And when you multiply all that out, it tells us to round to the nearest tenth, so we are not leaving this in terms of pi. You get 402.1 cubic units. We're talking volume. Okay. Part B, find the nearest tenth the volume of the solid by rotating the triangle about OB. Okay, I can do that. Just find some room. Once again, we've got a triangle that's like 6 here and 8 here. And we're going to rotate it around OB. So it'll look like that. Okay, very similar process here. Volume is 1/3 times, this time 36 pi, times 8. You might be thinking it's going to be the same answer. It won't be. It should be, I think, smaller. 301.6. Okay, and the reason it's smaller is that we have a smaller radius and a bigger height. So if you wanted to maximize the volume of your snow cones, you should make them short and fat, because that R gets squared. It has a bigger effect on the volume of the cone than the height does. Maybe that makes sense to you, maybe it doesn't. Okay, you'll be dealing with those kind of questions in calculus. Find to the nearest tenth the volume of the total surface area of the solid, surface area around AB. Now this one's going to be tough. Alright, I'm going to have to get creative here. I'm not exactly sure what this is going to look like. When we rotate it around the diagonal, is that what that's going to? No. Oh, this is going to be hard to undo all that. Okay, I think I know what it's going to look like now. This is going to go to here. and you're going to get what I would best describe as a dreidel. Okay, so let me try to redraw that for you. It's kind of like a kite, but it's been rotated. You feel that? Okay? So what we need to do is find the surface area of that thing. Well, isn't that like two cones put together without a circle involved? You know what I'm saying? So it's like finding... Okay, for the record, I think you should have gotten Part A and Part B. I don't think that's too difficult for any of you. It's new, so you skip it, and you guys got to get over that. You see something that's new, and you're convinced you can't do it. Okay? This Part C, I'm not expecting you to be able to do. This is like, hey, maybe you could do this, and if so, you're in the right class, because this is accelerated, and that's awesome. Okay? So, for A and B, again, I think those were pretty simple concepts. This one's more difficult. All right, so anyone remember the lateral area for a cone? That's exactly what it is. It's pi RL. If you didn't remember that, maybe you could think of it as 1/2 times the perimeter times the slant height. What's the perimeter of a circle? 1/2 2 pi r times L, and those cancel. That's how it comes out that way. Okay? So what we have to do is do lateral area 1 and lateral area 2, because we have two different radiuses and slant heights. Okay? Well, actually, we have the same radius, different slant height. What is our radius? Oh, we don't know. All right, so we can figure that out. This is such a good problem. Now I realize why they're giving us this problem. Because it like involves everything we learned this year. 6, 8, 10. Remember this? How do I find altitude? Yep, but I don't know what the parts are, right? So I got to just call this A and this B. 6 squared equals, excellent, good job, A times 10. So A is 3.6, okay? So then B is 6.4, right? So then I could just call this C. C squared equals 3.6 times 6.4. Can someone please do that for me? Multiply those and square root them. So that's the geometric mean between those, if you remember that. So C is 4.8. And that is actually this. Okay? That's our radius. So it's pi times 4.8 times, let's see, this one is 8, and that's 6 times 8, plus pi times 4.8 times 6, and oh, they want volume and surface area. Okay, so the surface area is 211.1. Where the heck are we? So it's 211.1 square units. The volume, let's see, now I got to find two different heights here. So can someone please do the square root of 8 squared minus 4.8 squared? What'd you get? Excellent, that makes sense because it's a 3, 4, 5. All right, so volume is 1/3 times pi times 4.8 squared times 6.4 plus, we're going to get the answer and write that down, 1/3. All right, so now I need you to do the square root of 6 squared minus 4.8 squared, Jess. Could you do that for me? 6 squared minus 4.8 squared. I'm thinking 3.6. Again, those are 3, 4, 5 triangles. Okay? So plus pi 1/3 times pi times 3.6 squared. Nope, times 4.8 squared times 3.6. And the answer for that is 241.3 cubic inches, or cubic units. And that is a tough problem. Boom!